Okay, so today is gonna try to record the contest. It's already started, but I'll sign up for this right now. No? Okay. Register, join. This one should be menu, should be easy. Close this one. Okay. So like solution is to build a hash map of characters and then sort them and then sort them. So I need to get the medium deletions. So I need to start removing the less frequent one, and then move up to the top until I have at most k distinct. Yes, something like that. So 4 int I equals 0. So I'll have this array with frequencies 26, and then 4 int I equals 0, I less than.
Okay, can I ask my mom about that? But I just want to see it. I'm just seeing it. You can't take it from me.
I++.
I know it. I'm not going to take it. Let me just see it. It's my pen.
And then frequencies of s char at I minus a plus. And then I go arrays sort and then fq, and then I'll need, so I guess default gonna be array sort frequency, and then I don't remember, will it be like sorted ascending or descending?
But don't say anything about me.
Lata,
Yeah?
can you go outside please?
Yeah, I'm going. I have my water. Okay, but don't say anything about me. What do you mean about anything about me? Example, like...
So I guess this is going to be ascending, so I need to take 4 int I equals 0, I less than, I would say unique. While fqi equals 0, I do I plus plus, and say int I equals 0, and then and I less than length here, and then and I less than 20 length. Okay, I plus plus. Oh, I go just from the top. FQ. So I'll have this for int I equals 0, I less than s length. I'll like FQ length I plus plus, and then I'll have this. Oh, I can have this in total here, total plus plus, and then I'll have the sort FQ, and then I'll go from the for int I equals 0, or like FQ length minus 1, I greater equal 0, I plus plus, and then I'll have this, let's say counter, or like so I just need this minus k. Minus into top plus equal FQI, and then I need to return total minus top. Okay, next one. So this one, so I can either solve it with binary search or just a prefix sum. Not prefix sum actually, because I cannot do that with prefix sum. Oh, okay. I can do that with prefix 1. Okay, so I'll have this int rows equals rows new, okay, int equals grid length, int columns equals grid 0 length, and then new maybe one rows and columns equal new rank equals so I'm gonna go for int I equals 0 I less minus r I plus plus, and then for int j equals 0 j less than c j plus plus, and then rows I plus equal grid I j calls j plus equal grid I j, and then I'll have this prefix sum for both rows and calls along p sum, let's say p rows new long r, and for let's say int I equals 0 or like row I less than r plus plus p rows I equals rows I plus p I greater than 0, then p rows I minus 1 right by 0, and then for int j equals 0 j less than c j plus plus, I wanna be p calls this one, equals j equals calls j plus the same j greater than 0, p calls j minus 1 otherwise 0, and then what I gonna do, I need to go for int I equals 0 for int I equals 0 I less than r minus 1 I plus plus, and then top if So I have here something like this. So let's say I have 1, 4, 2, 3 in this example. So I'll have the rows 5, 5 and columns I have 3, 7, and then P rows I have gonna have 5, 10, and here gonna be 3, 10. So in this case I need to find the cumulative sum. I need just to take P, let's say top, if P rows I is equal P rows R minus 1 minus P rows I, then return true. And do the same for the calls. For int j equals 0, j less than c minus 1, j plus plus, and then if p equals I equal p equals c minus 1 minus p equals I, then I'm gonna return true, otherwise I'm gonna return false. No, not yet. True. Case. False. No. Okay, next one. Maximum sum of edge values in a graph. Recording or no? This one is not. Okay, I guess I'm recording. Okay, maximum sum of edge values in a graph. You are given an undirected graph of n nodes, numbered from 0 to n minus 1. Each node is connected at most 2 nodes. The graph consists of m edges. Okay. So my idea is that I should assign. So it should be something like this, because there might be like something like this, connected pairs, or like something like this, like either vertex that's connected with one edge. Let's say there are like disconnected vertex. There is no edge, and there is whatever we assign to this vertex, it should be the minimal value, because I won't be able to use this value to increase the score because there are no edges. So separate vertices, because I get the score when I connect two vertices with the values, assigned values, and the score gonna be actually like multiplication of those two. And then I add all scores to get the total score. So when there is like isolated vertices that are not connected to other vertices, I just assign the minimal scores to them. Minimal available. So I'm gonna assign them in the last kind of order. What else I'm gonna do is to get the degrees of edges, so like of vertices. So this vertex has 0 degrees, this vertex has 1 degree, this vertex has 1 degree, this vertex has 2 degrees, this vertex has degree 1, and this vertex has degree 1. And then, there is like a trade-off actually. So my initial hypothesis was that I need to assign like top values to this connected, like to the vertices that have degree 2. So degree, so this is degree 2, this degree 1, degree 1, no, this one actually degree 0. So let's say so in this case I should let's assume I have this one. Can I find the counterexample? Let's say I have like 1, 2, to n. Okay, 1 to n. 1 to 6 in this case. If I assign this 6, 5, 4, 3, 2, 1. In this case, it's going to be 24 plus 18. And that's going to be 10 plus 5. So that's going to be 34, 42. This one going to be 15. Can I improve this one? If I gonna assign, here gonna be say you're gonna be 6, 5, 4, 3, 2, 1. In this case gonna be 24 plus 12, gonna be 36, and then plus 15. It's gonna be already 51. So it's bigger than this 42. So the question is how I should, what strategy should be used for assigning this, these values. So clearly, the isolated node should receive minimal values. And the question is how I should distribute the values between vertices that have degree 2 and the vertices that have degree 1. So the total score gonna be the sum of pairs. What happened?
Nothing.
Why are you hitting the door?
Just so my just.
Oh, okay. So the sum of multiplications.
Yeah, come on, I'll get you some.
Say score I, score j, and then it's gonna be. Yeah, some kind of this formula. And I need to get the maximum areas. So I want to reuse this maximum values as much as possible. So it means that what if I do the 5 here? Can I do bigger? Bigger value? As if I do 5 here, 5. If I do 4, okay, gonna be 3, 2, 1. So it's gonna be 30 plus 18 plus 8. And it's gonna be even bigger, like 56. Okay, wait, what was the previous one again? Value, so it was 5, here 4, 3, 2, 1. So it was 24 plus 12. No. if I'm gonna gradually fill it up? So 4, 3, 2, 1. 24 plus 18 plus 10 plus 5. It's gonna be 34, 42 plus 15. It's even bigger. 57. What if I'm gonna do like something like this? 5, 4, 3, 2, 1. So it's gonna be instantly 30 plus 24 plus 6. Even bigger, 7, 60. Charisha, come home. Your mom is asking to come home.
I knocked on the door. She wasn't answering.
Yeah, she's asking you to go home.
Oh. Since when did you have her phone number?
Since I don't know. So it might be worth, like, I guess, doing this allocation to the pairs that have. Yeah, such a weird task. So here they allocated first to the nodes that have that are in a cycle, actually. But it's not always gonna be true. This is a good counterexample. So this one, I guess the maximum I can get is 6, 5, 4, 3, 2, 1. So it's gonna be 30 plus 24 plus 6 plus 3. Gonna be 63. If I gonna allocate the 5 to degree to this to the vertex of degree 2 in this case, because like here in the cycle they start allocating top values to the vertices of degree 2, and here also of degree 2. But in this case, can I make any kind of value bigger than 63 in this case, if I allocate top to the vertices of degree 2? So if I do 4 here, 3 here, clearly this one is, let's check. The last step is obvious, like I should allocate 2 to the bigger value. In this case, it's gonna be 18 plus 12 plus 20 plus 5. Gonna be 30 plus 55. Okay, can I do something like this? So if I allocate here 4, 3, 2, 1. Give me 24 plus 18 plus 10 plus 5. It's gonna be this one 42. I feel that like here I should like first detect the cycles and allocate all top values to the cycles. And then I should allocate top values to the vertices of degree 2. And then remainders I should what do? Let's say no, actually no. So the cycles somehow have the priority. Why? Because in a cycle, top values can be reused twice. Like, so if I assign it, let's say top value here and here, instead of like assigning it here and here. So this value gonna be reused twice here, here, and this value. Okay, this is the same here and here. But this value in this case gonna be reused once, only in this pair. But this value you assigned here gonna be reused in this pair and in this pair. And another observation is that I should assign values in a cycle by doing BFS. So I have to do like 7, 6, 5, then 4. Because otherwise, if I'm gonna go just through this one, like 7, 6, 5, 4, I can improve. Can I improve in this case? 7 by 4. It's gonna be 7 by 4 plus 4 by 5. And in this case, plus 5 by 6. And otherwise it's gonna be 7 by 6 plus 6 by 5 plus 4 by 6. So this one is the same. So in this case it's gonna be 48, and in this case it's gonna be 42 plus 24, 66. So I should do in a cycle, I should assign values using BFS, and in a That's not that obvious. What should I do in a... Also do the same? Okay, let's check the other one. So this connected criteria, if it has like 4x4 grid, let's say I have this one, I can remove this one, cell, and still like cells gonna be connected, I assume. Mm. Can I adjust my previous approach with prefix sums to this one condition? If I'm gonna have some kind of hash map of values in a lower part or upper part, or horizontal or vertical, or left or right, and then I can calculate the sum and calculate the prefix sum and like check the diff if there is a diff, and check if there is a number in the left part or right part. So kind of this approach, but like with a lookup map. So I'll have this hash map of, let's say, integer, and then I'll have integer, let's say, array list of integers coordinates, and then I'll have this get or default grid ij, and then here new array list, and then array list integer, and then I wanna add new and ij, and then put grid ij a. Yeah, the problem is gonna be if it's gonna be the same values. And delta equals top equal. So in top I need to find this so because they are positive delta, okay, it's just delta minus. If it's gonna be delta positive, if delta equals 0, return true. If delta less than 0, search in upper part, search in top part, and then here else, search in bottom part, and then here the same, the delta like long delta equals if delta is equal 0, return true, else if delta less than 0, search in left part, and here else search in right part. So to search, so I need to go list int a equals m dot get math amps delta, and then for int I equals 0. That's a linear search. I don't like it. How I can improve the linear search? Whatever, let's implement file as an, let's say let's ij k equals 0, k less than a length of size, k plus plus, and then if int p get equals a dot get k, if p plus p0 plus equal I, return true. Is greater than I. Same. P1 less than J, return true. And the same here. Greater than J, return true. What? No, still not working. Okay. Where? 86. But where I was adding that? Oh. Oh, yeah, the same. Oh no. Should be true here. Why it's false? Where is the error? So maybe let's print if delta less than 0, then it means I should remove it from here. Yeah, so something like this. And here also. Still false. Huh. This one is weird. False. So let's think about this again. So if this one is less than 0, if delta is less than 0, that means this is smaller, this is bigger. That means that I should remove from this side, from the lower part. Still, okay, let's print out the 4 equals 0 less than. Let's print out m. What it will show me. 4 int I for like key key set system like list list int p pairs equals m dot get key for int I equals 0. Let's say I equals 0, I less than ps length. Let's say size. System out print key plus key, and then system out print line and code out print what. PS get I what will it print me? 1 0 0 2 1 0. Okay, 3 1 1 4 0 1. That's right. Then here okay, so here I should exit here, like splitting vertically, like not here, like there, somewhere here, if delta is greater than 0. So delta gonna be what? So in this case, delta gonna be what? 1 3 4 6. 4 minus 6 gonna be the system out println v delta plus delta. V delta minus 2. And then I'm gonna jump here. Delta will here minus. Don't understand. Let's say just print. Okay, so it jumps here. I just cannot find it, but it should be there. Or I don't understand something. Let's try to do this one. Say Leetcode open. Okay, do I have Java here? No. Okay. Okay, I'm gonna wrap up now.